In this session we will see about the shear reinforcement. So in a design of beam, this shear reinforcement is very important component. Okay. So if you are taking this, so this is the reinforcement diagram for the beam. Okay. So will you please tell me the types of beams? Singly? So what is the difference? Singly reinforced, how the reinforcement will be there? In a tension zone, main rod will be there. In compression zone, there will be hanger parts. Doubly reinforced beam, both in tension zone and also compression zone, we will provide the main rods. Yeah. So here, if you are seeing that, so this is the beam. How the loads are acting? Slab level. It is a beam. Okay. So here, if you are seeing here, this two. So here, if you are taking this this blue line, both are main rod. In case of doubly reinforced. Okay. We are calling that as the longitudinal. Okay. So how this is the sectional view. Okay, ma. So if you are seeing that this vertical line, so this is nothing but shear reinforced. So what is the another name for shear reinforced? Yeah. So if you are seeing that, how the spacing between the stirrups in mid span is more. Okay. And here at support it is very closely placed. So the reason is this. The reason for providing the shear reinforcement is to take care of shear condition. If you are taking any beams, that shear will be maximum at support. Okay, ma? If you are taking that, the shear force will be somewhat less at the mid span. Okay, ma? So here in support, the shear force is more. To take care of the shear force, we are providing the shear reinforcement in very close. Okay, but in mid span, it is a somewhat, we are providing some more space. Okay, so now if you are seeing that these are all the reinforcement, that's a main bar, and the other one is the shear reinforcement. I think you understood. Okay, so what are the shear failures which are occurring? So will you please name the modes of failure? Someone?
Flexure failure,
Very good.
and diagonal tension failure, shear compression.
Very good. Okay, good. So flexural failure, diagonal tension failure, and next one is a shear compression failure. Okay. So please someone explain about each and every type.
Flexural failure, the crack will mostly form in vertical.
Very good.
And the mid-third of the beam.
So it is mostly occurring mid-third of the beam. Very good. So what is the second type?
Another one is diagonal tension failure. Whenever the diagonal tension failure is less than the flexural strength, will appear on the shear reinforcement.
Okay. Whenever the diagonal tension strength is less than the flexural strength, these types of failure will occur. So what is the third type? That's a shear compression. So when how it is anyone?
Where the beam has a smaller shear span, depth ratio of the magnitude to 1 to 2.5 concentrated loading, less than 5 for distributed loading.
So whenever if you are taking that span to depth ratio. So what is the span to depth ratio? It is a span and it's a depth. We will do the L by D ratio. Okay, so if it is 1 to 1.5, whenever the concentrated load is acting, okay, this shear compression failure occurs. Whenever the UDL load is acting, this span to depth ratio is less than 5, this type of failure will occur. So therefore, so in future you are going to work somewhere. Okay, so you have to see that whether any cracks are occurred there. The reason will be if you are the base mostly the failures or cracks which are formed in the beams will be either three reasons. Okay, so if you decided if you are seeing in a beam vertical, it is a flexural failure. Okay, so if you are not providing the stirrups, okay, but whenever if you are bending that stirrups, that the stirrups should be bended properly. So which means here you can see this how the stirrups are bent. So here you can see this for calculation of this bending length also the caudal provision is there. So in SP16 they have given how much angle it should be bent and how much length. Okay, so if the bar bender is not provided this hooks, the technical name is hook. HOOK. Okay. So whenever this angle is not provided, it will be occurred. Okay. So here these are the types. So now the types are vertical stirrups, U-shape,
Multi-leg stirrup.
and then
Bender
bender
bars.
bars. So these are all the types of stirrups. So according to the requirement, we will provide either bender or it may be a vertical or anything. Okay, but so whenever if you are seeing the failure, you should decide this is the type of failure and you should know that the reason. If you are not